Hello everyone, welcome to the operating system series. We are doing the CPU scheduling algorithms. So in this session we will be doing the priority scheduling. So we will see how this particular scheduling is handled. So in this case, when the first process arrives, we see that we will see the two parameters. One is the CPU burst. The CPU burst is 7 and the priority is 2. And when process P2 arrives, we see the CPU burst is 5 and priority is 3. And when process 3 arrives, we have the CPU burst as 6 and priority is 0. And when P4, with respect to P4, we have the CPU burst as 4 and priority as 1. So here we see there are two parameters. One is the CPU burst, other is the priority. So for selecting the process, we don't see what is the CPU burst is, but priority is seen. As we can see, the priority numbers are given 1, 0, 3, 2 and so on. So in some cases, the process having the largest number of the priority is selected, and in some cases the priority number which is the least is having the highest priority. Okay, so let us consider that particular case. So in this particular example, we see that the priority of P3 is, we can see 0. So this is having the highest priority, and then after that 1, P4, 2, P1, 3, P2. So this is the order in which the process are selected. So for selecting the process, the criteria which is seen is the priority. Okay, so this is the criteria for selecting the process. So as we can see that P3 is having the least priority number. Okay, it is having the smallest the priority number. So this is having the highest priority. Okay, so P3 is selected. Then after this gets executed, the next is the next smallest priority number is 1. So it is selected. Okay, it is having the highest amongst the process left. Then after this we see that P1 is selected, okay, which has priority number 2. So P1 gets selected, and after this the last one, P2, is selected, which has the least priority. So this is the order in which the process are selected and executed. Let us see one example. So this is the priority scheduling, and this is how we define it. The process having the highest priority is executed first, and then so on. So here we have an example. We have some set of processes. So we have P1, P2, P3, P4. We need to find the average waiting time and average turnaround time. So we have this process P1 with CPU burst as 4 and priority number is 1. Process P2 with CPU burst as 6 and priority number 0. P3 with CPU burst 5 and priority 3, and process P4 with CPU burst 7 and priority number 2. Now in this case we consider that the process having the smallest priority number is executed first, which has the highest priority. Okay, so in this case we see this is executed first. Okay, so we draw the Gantt chart for this. So this is the Gantt chart. Okay, so process P2 is executed. It has CPU burst as 6, so it executes from up to 6. Okay, 6 time units. If it is milliseconds or 6 milliseconds, then after this the next process which has the highest priority is this one amongst the remaining process. So this is executed, so it has CPU burst is 4, so 6 plus 4 is 10, so this is 10. Then after this we have two processes P3 and P4, and we see that this number is smaller, so this P4 is executed, so we have 10 plus 7 is 17. Okay, and then finally we have this P3 process which has the least priority amongst all the processes. So this 17 plus 5 is 22, so this 22. Okay, now we see first the waiting time for the individual processes. Now how to find the waiting time? As we know that we have to see where the process starts. So P1, it starts from this 6, okay, 6 time units. So this is 6, it has to wait for 6 milliseconds if you consider the time as milliseconds. And P2, it has to wait for 0 milliseconds. It is executed first, so it doesn't has to wait any time, so it is 0. And P3 starts from 17, so this is the waiting time for P3. And P4, it starts from 10, so this is the waiting time for P4. Now to find the average, we add all these 4 numbers and divide by 4. So we have this, okay, 33. I think this is divided by 4 is 8.25 millisecond. Okay, so this is, if the time is in milliseconds, we get this all divided by 4 is 8.25 millisecond. So this is the average waiting time. Now let us see how to find the turnaround time. We again draw this Gantt chart here. Okay, now for getting the turnaround time is the time where the process ends, so it is waiting time plus execution time. So here for P1 is ending at this point, so this is the turnaround time for P1, so this is 10. For P2 the turnaround time is 6, so this is 6. For P3 the turnaround time is 22 because it is ending at that point, and for P4 we have 17, so this is the turnaround time for process P4. Okay, 17. So now average turnaround time is adding all the 4 divided by 4, so 10 plus 6 plus 22 plus 7 20 is 4 divided by 4, so we have this as 13.75 millisecond as the average turnaround time. So this is how we do the calculation. Okay, so this is how the prior to scheduling is executed. So that's all for this particular session. Thanks for watching.